Before we begin Unit 27, here is the answer to the Unit 26 question. The best answer is choice A.
Water is often referred to as the universal solvent because it dissolves so many things. Nature is able to clean water for us and does so using nothing more than natural physical or biochemical processes. Of the two major water pollution problems, the extraordinary amount of biological waste is the least difficult to address, whereas the introduction of synthetic and non-biodegradable substances is more difficult and must be handled on a case-by-case basis. Wastewater treatment refers to the steps taken to prepare contaminated water for discharge into a receiving water source. Water treatment refers to the steps that are taken once water is removed from a source in order to make it safe for drinking. Water treatment uses a series of filtration, disinfection, and sometimes pollutant-specific procedures to make sure that water is both potable, drinkable, and palatable, tastes good. Unit 27. What a waste.
The term solid waste is a bit misleading because it refers to any unwanted material that we throw away, but sometimes the substance or parts of it are actually liquid or gaseous in nature.
If the material is particularly dangerous, it's referred to as hazardous waste.
The handling and management of hazardous substances differs significantly from that of ordinary solid waste.
The major problem associated with non-hazardous solid waste is the sheer volume.
If you reflect on how much garbage you generate on a daily basis and then extrapolate the amount of waste produced in one day in New York City alone, you'll immediately realize the problem.
Where does it all go? Why aren't we up to our wastes in waste?
The truth is that people have come up with some ingenious methods of dealing with solid waste.
Environmental scientists use an integrated waste management system that attempts to couple waste prevention and reduction methods with responsible disposal practices.
Integrated waste management, or IWM, follows a three-priority approach.
The first priority is to prevent the primary or original pollutants from being produced.
This can be accomplished by changing manufacturing processes, using less of an unwanted raw material, reducing packaging, and making products that last longer.
The second priority involves reusing, recycling, and repairing existing products in order to minimize secondary waste.
Sustainable companies have programs in place that not only reduce the amount of solid waste generated, but also save money and improve the corporate bottom line.
The third priority is to manage or dispose of those primary and secondary wastes that could not be eliminated.
It's important to understand that when it comes to solid waste, or any type of pollution for that matter, there really is no way to eliminate the problem. The best we can hope for is to reduce the pollution's impact on the environment. Current solid waste disposal technologies include incineration, landfills, or the release of non-toxic substances to the environment for dispersal.
One method of managing solid waste is to incinerate or burn it at very high temperatures.
Incineration results in substantial reductions in solid waste volume, concentrating materials for ultimate burial, so it's not really a final disposal strategy.
In some cases, the energy released in the incineration process can be harnessed and even sold to reduce operation costs.
These waste-to-energy recovery facilities, however, are only economically feasible if they handle high volumes of trash every day. This unfortunately encourages trash production and discourages reuse, recycling, and waste reduction.
The obvious disadvantage of incineration is that the process produces air pollution, so in a way, we are only exchanging one type of pollution for another.
Incinerators are also expensive to build, and no one wants to live near one, so there's always the NIMBY, or not in my backyard, syndrome to deal with.
Garbage was once disposed of in open dumps that were really nothing more than big holes in the ground. There were obviously many problems associated with that practice.
Today, solid waste is disposed of in what are called sanitary landfills that are designed to minimize environmental impact.
Sanitary landfills are usually built in geographical areas that are less prone to groundwater contamination.
Strong liners, containment systems, and collection pipes are used to ensure that rainwater contaminated by wastes, referred to as leachate, does not reach the groundwater.
Every day, trash is evenly spread over a section of the landfill and covered with soil or other appropriate material in order to keep the waste dry, reduce odor, and discourage rodents.
Landfills collect and burn methane that is produced by the natural biodegradation process, and in some cases, this energy can be used to help offset operational fees.
Sanitary landfills have low operating costs and are able to handle large amounts of waste.
Also, when completely filled, the area on top of the landfill can be reallocated for other purposes, such as parks, wildlife habitats, or golf courses.
Like incinerators, an obvious drawback is that nobody wants to live near a landfill.
In highly populated areas, there simply isn't enough space for these facilities, and waste is often transported far from origin.
Landfill operations increase noise, traffic, and dust, encourage waste production, and release greenhouse gases.
Eventually, all sanitary landfills, no matter how well built and maintained, will fail, and leaks will contaminate groundwater.
The major issue with simply releasing non-toxic substances into the environment for dispersal is that it's only a viable option when the quantity of waste is negligible and the area of dispersal is adequate to ensure that there will be no negative health or environmental impacts.
Unfortunately, none of our solid waste disposal options provide us with a perfect solution.
As such, solid waste prevention and reuse strategies are and must continue to be our top priority.
The three-priority approach of integrated waste management applies to hazardous materials as well. However, there are some important distinctions, as these substances pose an immediate threat to human health and the environment.
The first priority is to minimize the amount of hazardous waste produced.
The second priority is to recycle and reuse as much of the waste as possible using strategies such as natural decomposition, incineration, thermal treatment, chemical reaction, or dilution to non-toxic levels.
Phytoremediation, a process in which plants function to remove and render hazardous chemicals innocuous, and the plasma arc that detoxifies hazardous waste are examples.
Perpetual storage is the third and least preferred priority option in the management of hazardous wastes.
Ultimate disposal methods associated with hazardous wastes are obviously much more complicated, regulated, and monitored than those associated with ordinary solid wastes.
Some common strategies for perpetual storage of hazardous materials include deep well disposal, surface impoundments, secure hazardous waste landfills, and injection into underground salt formations.
All of these disposal methods are very expensive, and although quite safe if monitored and maintained properly, there can never be a guarantee of zero future risk.
One of the biggest problems associated with hazardous waste is illegal disposal.
In order to avoid very high management costs, some individuals turn to illegal dumping, a practice that has obviously had many serious environmental and health consequences over the years.
In the 1980s, the Comprehensive Environmental Response Compensation and Recovery Act, also known as the Superfund Act, was enacted by Congress.
The Superfund program identified extremely hazardous waste areas called Superfund sites and set goals for remediation.
Superfund also made polluters responsible for paying the cost associated with cleanup. This obviously reduced the occurrence of illegal disposal, but has certainly not eliminated the problem.
Today, anyone generating hazardous waste must register under the Resource Conservation and Recovery Act for a permit to produce and dispose of hazardous substances.
These hazardous waste generators must conform to a cradle-to-grave tracking system to ensure that proper disposal is taking place.
I'll bet that you never knew all of this garbage.
Here's your question for Unit 27.
Which of the following statements is false?
Choice A. The major problem associated with non-hazardous solid waste is the sheer volume.
Choice B. Integrated Waste Management, or IWM, follows a three-priority approach.
Choice C. Hazardous waste poses an immediate threat to human health and the environment.
Or Choice D. Most methods for disposing of hazardous wastes are relatively inexpensive.
The answer and explanation are provided at the beginning of Unit 28.